Hello and welcome to class. In today's lesson we'll look at Applied Chemistry 2, and in this lesson we're looking at the process and the product made from chemicals. Okay, remember in our last lesson we look at fine chemicals and heavy chemicals. In today's lesson we'll look at plastics, metallurgy, pharmaceutical, glass, ceramics, paints, cements, soap and detergents, and then we'll now look at the economics of the chemical industry, and then we'll look at importance of industrial chemistry. Okay, you already know the difference between heavy chemicals and fine chemicals, is it not? I already know what fertilizers are and why they are very important. Today we'll look at plastics. Now, plastics are very useful materials. Initially, they were made from coal, limestone, cellulose, molasses, okay? And of course, they were made from latex, is it not? That whitish liquid obtained from tree. It contains isoprene. Isoprene is actually 2-methyl-1,3-butadiene, okay? From coal, we obtain benzene. This benzene is converted into ethyl benzene, and then ethyl benzene will now be converted into phenyl 18, okay? And this phenyl 18 is what undergo polymerization to form what we call polystyrene. This material is what is used to make what? Plastic. So from coal, we use what we call polyphenyl 18, or simply what? Polystyrene, to make these polymers that are used to make plastic. Now, phenol is also obtained from coal, okay? Phenol, methanol, and urea, they are also obtained from coal. You can see their structure. They are used for the synthesis of what? Wide range of thermosetting plastics, all right? You should know that. These ones are also converted. They are used to produce what we call thermosetting plastics, all right? Thermosetting plastics are different from thermoplastics because they are resistant to heat, and then they are also not recycled, okay? They cannot be recycled, unlike thermoplastics that are easily recycled and are not very resistant to what? Heat. And then limestone, when heated with coal, we produce calcium carbide. This calcium carbide, when treated with water, produces ethine, and ethine, when further treated, we produce vinyl chloride. This vinyl chloride is what is used to make polyvinyl chloride. You can see vinyl chloride, a 18 molecule that has been substituted with one chlorine atom, okay? We also obtain plastics from molasses. Molasses is a dark brown liquid obtained from the refining process of sugar, or what we call cane sugar, okay? And it is a very complex process, of course. First of all, it is converted into alcohol through a process known as simultaneous saccharization fermentation, SSF, okay? After converted to ethanol or alcohol, it will now be dehydrated, okay? It is the dehydration of this alcohol that yields the product what? Ethene. And then addition polymerization will take place with ethene to form what? Polyethylene, or what you call polyethylene, which of course is used in making what? Certain type of what? Plastics. All right. A wide variety of plastics are now made from the distillation process of what? Crude oil, okay? Modern plastics are made from crude oil these days, no longer the one we just explained. Why? Because it is more easier and have it in abundance, okay? Now, the modern plastic process that is making it is actually of two types. First is called the injection molding, while this one is called the extrusion. Both processes involve, first of all, heating the materials so that it melts, and then shaping it and setting. Setting means allowing it to cool in the mold before finishing your material. Now, in the injection process, the mold or the material filled in form of granules into the system, and then the system consists of the heating elements, okay, which are divided into three areas. You have the metering zone, you have the transition zone, and you have the feed zone. The feed zone will carry the materials, and because of friction, the materials heat will be generated that will melt the materials before it gets to the metering zone. Okay, from there it is cooled by dosing, okay, before it is now pulled out, and the process is what repeated again. The pressure in the systems ensure that there is no deformity in the material being produced. Okay, by deformity I mean you don't produce your plastic, then they will not be having holes inside. In extrusion process, it is similar, but here the materials are carried as shown. Okay, you can see as it's rotating, it's carrying the granules. Friction will make it to melt, and then it is used not to make mold, but most times to cover materials. Okay, for example, wires are being covered by this method. All right, metallurgy is the science of extracting metal from the ore. Okay, it's usually done in two steps. You concentrate the ore and then you rust it in air before processing to get the fine metal. All right, of course this material are very useful, is it not? Yes, for making alloy, for making steel, and other important bars for structure. All right, we look at pharmaceutical. Pharmaceutical, of course, is the making of medicine cure certain sickness in the body. Aspirin is the most widely used drugs, okay, obtained from coal tar. Then we have the glass industry. The glass industry consists of small grains of quartz crystals made up of molecules of silicon dioxide, which is also known as silica. How do we obtain glass? By heating this to a very high temperature. Okay, we obtain the glass, which is now made into different molds or shapes. Okay, it's very important you understand this. There's a principle for it. Here, sand, soda ash, limestone that are melted to a very high temperature are used to form the new material called the glass. Like I told you, just like the way we pour the mold of the plastic, we also pour the mold of the glass into its mold, is it not, to obtain the fine shape. And I told you we have a variety of uses for glass, is it not, ranging from your bottles to your glass window, even to your eyeglass. They are all made of glass. The next one to look at now is ceramic. Ceramic is made from silica and the oxides of certain metals, such as magnesium, aluminum, zirconium, thorium, titanium, and then boron. Okay, some artificial ceramics are now being made from carbide and nitrides. Okay, paint, which is a fluid mixture which contains suspended materials, are actually useful in coating other materials. Okay, it is made with three important components. We have what you call this solvent, you have the pigment, and then you have the binders. Okay, the pigment, an example is titanium oxide, gives you the coating. The solvent is a liquid that reduces the thickness, while resins and additives are called binders. They help to hold the materials together so that it forms a uniform mixture. Cement, of course, is obtained by heating powdered lime, which is calcium oxide, with clay. Okay, it forms what we call mortar. Mortar, when exposed, become very thick. Soap and detergent, a chemical formed from reaction of fatty acid with alkali, is it not? Yes, this soap is formed after the process. You add salt to it, and then you scoop the top part away, which contain excess sodium hydroxide and the salt, before you now further treat it to get the fine soap particles that you desire. Liquid soap and detergent, of course, are made by chemical synthesis. Okay, you have different chemicals to get your liquid soap and your detergent. Now, soap is very powerful because it has the ability to remove grease and stains from materials, is it not? Yes. The next is food and what? Drinks. Now, food preservatives are produced by chemical synthesis, and then most drinks are preserved by also chemical synthesis. For example, the injection of what? Carbon dioxide into drinks, is it not? And then the fermentation process of making what? Alcohol. Remember, the fermentation process of making alcohol is a careful process that ensures that we don't have excess fermentation or less fermentation, so that we can obtain the alcohol that we so desire. And this is applied in the brewing industry, which also liberates carbon dioxide as a byproduct that can be used as a injection into what? Drinks. Economics of industrial processes. You have raw materials, energy requirement, and then transportation. Your industry must have the following: there must be availability of raw materials, enough energy requirement, and then there must be transportation to bring in raw materials and send in finished product. Then the material you are producing must be able to undergo recycling to reduce the waste and save natural resources. Then the supply and demand chain must be balanced. If, for example, you are making a product that is becoming obsolete, what you need to do is change your product to what is now being accepted. You understand? Let's say, for example, in those days there is high demand for lighting stove, but modern days there is high demand for gas. So you change your production from lighting stove to what? To gas cylinder, so that your supply can meet your demand. Importance of what? Chemical industries. There are three main importance: provide earnings, improve standard of living, and also provide employment for citizens. Okay. All right, that now brings us to the end of today's lesson. Remember to do other activities in this lesson. Stay safe. I'll see you soon.